Hello, welcome to lesson 7. Let's talk about angle relationships. Your learning target is that I can find unknown angle measures by reasoning about adjacent angles with known measures. And I can recognize when an angle measures 90 degrees, 180, or 360. Starting off with 4 of our angle classifications, we have our right angles, which are angles that measure 90 degrees. The sketch would be something like this. As long as there's that little box, you don't have to actually get a ruler out and a compass out and measure it and a protractor and all that. As long as this little box, that right there means 90-degree angle. Next we have acute angles, which are angles that measure less than 90 degrees. It's a couple of sketches for you. They're the smaller ones. Obtuse angles, the opposite. They are the angles that measure more than 90 degrees, so something like that is obtuse. And then straight angles are angles that measure 180 degrees. They are our straight lines. So to draw that, you would just show that right there is an angle that measures 180 degrees. And I'm just going to throw on here also, because I'm not sure what kind of prior knowledge y'all are coming in with, but a circle around the center measures 360 degrees. So 360 is a full circle. Maybe add that to your notes. So when we start to write angles, there are some really specific ways that we do that, and often you'll see it done with letters. And so here we have a figure, we have a whole bunch of letters, A, B, C, and D. And first, let me just ask you, which angle is angle A? So if we're just looking here, so you wouldn't want to call any of these angle A, because angle A could mean a whole bunch of different things here. Here's the symbol for angle. It looks a lot like less than, but that's angle. Angle A could be this angle right here. It could be 60 degrees. Angle A could be, I'm going to put a question mark there, it could be this one right here. It could be 50 degrees. Angle A could be this whole angle. So it could be 90 degrees. Oops, I can totally add. It could be 110 degrees. We want to be more specific when we start to write about angles. So it's not good enough to just say angle A, because it could be multiple answers. Let me get that all erased. So when we want to refer to specific angles, we want to use 3 different letters. We will start with an outside letter like D, move to the letter that is at the vertex of that angle, which is our A, and then talk about which specific angle we want to reference. So let's start with C. So we could then say that angle DAC is 60 degrees, because it would be this one right in here. Likewise, we could talk about angle CAB, which is 50 degrees. Both acute angles, but very different measure. And these angles right here are called adjacent angles because they share a leg. So they have this common leg that we would call leg CA. So since they have that in common, they are adjacent angles. We will talk more about what adjacent angles are, but there we go. And also when we're writing angles, angle CAB is actually the same as if we wrote it backwards. So we could also call it BAC. That is also a 50-degree angle. These are the same angle. Just changing the movement. So BAC would say there's B to A, and then A up to C. CAB would be C to A, and then from A to B. All right, I want you to do a quick you try it just based on some of the stuff we just talked about. We have a bunch of adjacent angles here. Go ahead and just answer these, check back in, make sure we're all on the same page. All right, and here's your answer. Since angle A is making a square, so in this case we can just call it angle A because it's all by itself. So that is angle A. And since it's the corner of a square, that means it's a right angle or 90 degrees. So if you have 3 of them, the angle it creates right there is going to be 270 because 90 plus 90 plus 90 is 270. And then this angle right here, when you have 4 of them, is that full circle we were looking at, and that is our 360 degrees. All right, let's talk about some angle relationships. This is really just going to be writing down definitions and looking at how these are similar or different. But starting with adjacent angles, we already kind of talked about them, but they share that side and a vertex. So that vertex being the point where the angles come together. So in this case, the vertex is that point B. And the shared side here is the line BC. So we would say that in this diagram, angles ABC and DBC are adjacent angles. Next, we're looking at vertical angles. Vertical angles are opposite to one another, and they share the same vertex. So here, our vertex is this point E. So they are formed by a pair of intersecting lines, and their angle measures are always equal. I would definitely highlight that their angle measures are always equal. And so in this case, our vertical angles are right here and here. So we could say that angles AED and CEB are vertical. And also, we have a set of vertical angles right there. So we could also say that angle AEC and DEB are vertical, therefore having equal measure. So next up, we're talking about complementary angles. So complementary angles have measures that add up to 90 degrees. They don't have to be adjacent, meaning they don't have to have that shared leg. They can be separate. They often are adjacent, but the important thing is that they are angles that add up to 90 degrees. So in this case, or for example, if we had a 15-degree angle and a 75-degree angle, those are complementary because they equal 90. Right here, what we have is one angle that is 64 degrees, so we would call that DAB. And we want to know then that what this one is. So we could work some backwards, and we could say, well, if these are complementary angles, then they have to add to be 90. So then inverse operations, 90 minus 64 equals 26. So then angle CAD has to be 26 degrees. Okay, and then lastly, we'll have supplementary angles. Supplementary angles have measures that add up to 180. And again, they don't have to be adjacent like the one in the figure, but they often are. So for example, a 15-degree angle and a 165-degree angle would be supplementary because 15 plus 165 is 180. So here we have 2 supplementary angles. So angle SOP and POR are a set of supplementary angles. Angle POR is 76, so then this angle right here would be 180 minus 76, which equals 104. So that means this is a 104-degree angle right there. All right, go ahead, grab your journal problems, let me know how I can help you. I know this is just a lot of memorization, but take good notes. You can have notes on a test. Thanks, y'all.